My name is Linda Kern, and for any of you who don't know me, I'm one of the social workers and patient services coordinators with ALS of Michigan. Also joining me tonight from ALS of Michigan are Judy Fortuna, patient services coordinator, Mary Hansen, social worker and patient services coordinator, Lisa Bardak, our speech and language pathologist, and Sue Burstein, our executive director. I feel privileged that our speaker this evening is Dr. Stephen Goutman, Associate Professor in the Department of Neurology and Director of the ALS Clinic at the University of Michigan. Dr. Goutman has a degree in neuroscience from Johns Hopkins University, a medical degree from the University of Chicago Pritzker School of Medicine. He completed his residency in neuromuscular fellowship at Cleveland Clinic and received his master's degree in clinical research design and statistical analysis at the University of Michigan. Dr. Goutman's research is focused on identifying causes of and treatments for ALS. His research efforts have received funding by the National Institutes of Health and Centers for Disease Control, aimed at identifying environmental risk factors and causes of ALS. Dr. Goutman received a 2016 Young Investigator Award by the World Federation of Neurology Research Group on Motor Neuron Diseases. So would you all please help me in welcoming Dr. Stephen Goutman.
Thank you for the very kind and unnecessary introduction. Sorry that I'm a little late. Getting out of Ann Arbor was a challenge this evening. For those of you who have done it before, it's nice to see some familiar and some new faces in the audience tonight. It's really an honor and a privilege to be here talking to you about the really exciting work that we're doing to piece this story of ALS together so we can really make better inroads into treating this disease. I don't need to tell this audience about ALS. You know it, you're living it. But we know that about 6,000 people per year are diagnosed with ALS. About 20,000 people a year are estimated to live in the United States each year with ALS. I'm going to make two plugs, one right now and one in a little bit, for the National ALS Registry. It is really important for us to have everyone who has ALS register with the registry so we know how many people have ALS and where they're living. This really supports our ability to get funding for this disease, to make policy changes so we can make life living with ALS easier. And so I'll make another plug for that again later in the talk. We know that ALS is not entirely explained with genetic factors. And so those of you who've seen me or go to other clinics will hear people talking about genetics, and we have to test genetics, and it's really, really important. But we know from studies that the genetic heritability, what we think of as the amount of ALS that you can contribute to your genes, ranges from 60% in twins to kind of 20% in all comers. That means there's 80% of causes to 40% of causes that are not due to genetics, but are due to environmental factors. And we really need to spend more time understanding and learning about these so we can better understand the disease. We put this together in a model that we call the gene time environment hypothesis. And so you'll see two, you'll see two graphs here. And I want you to pay attention to this square here, or I should say call it a rectangle here and a rectangle here. These are our genetic susceptibility that we're all born with to any particular type of a disease. It can be ALS, it can be high blood pressure, it can be diabetes. And as we age, all of our cells undergo damage. That's just a part of normal aging. But then we're all uniquely exposed to what we call these environmental risk factors. And if we get to a point where there's a sufficient number, so if we fill in this box here, where you have a sufficient amount of these environmental risks, it pushes you so that you develop disease. And so that's called the gene time environment hypothesis, and these are the pieces that we need to fill in to really understand why people are getting ALS. Now this is really This is really important for those of us that live in Michigan, because Michigan in the Midwest is a location that has higher rates of ALS compared to other parts of the country. And so this is a display of individuals who's passed away from ALS between 1999 and 2009, and you'll see that ALS really affects the northern states more than the southern states. And in data from the CDC, who runs the National ALS Registry, the incidence, what we calculate as the incidence of ALS, is higher in the Midwest. So there's more people coming down with ALS in Michigan. So we need to pay attention to this to understand why ALS is happening here in our own state. We've started to think about this in regards to where people live and where we know there are sites of environmental pollution. So the map, the mitten on the left, is where people have sort of passed away from ALS in the state. The darker the color, the more deaths that there are. And on the right are all the sites of environmental waste sites, so Superfund sites, places that have been identified as areas needing cleaning up by the government. And if you kind of, in your head, sort of superimpose these two mittens on one another, you see that there appears to be this sort of lining up of where people are passing with this disease and where the sites of pollution are. And so this is what's spurring us to better understand what's going on. So why should we think about environmental risk, right? So this is not the type of information that everyone's talking about, you know, when you get into the support groups, and when you go to other clinics, and when you kind of hear about ALS. It's not really people saying, we got to study the environment, we've got to study the environment, right? So I want to tell you why. So the initial descriptions of ALS in the 1850s included, of the 11 cases, 3 people had a history of lead exposure. And in the 1960s and 1970s, there was an understanding that heavy metals, pesticides, and athleticism were risk factors for ALS. And then what really sort of pushes this into the forefront is this notion that the incidence of an ALS-like disease in Guam was 50 to 100 times higher than it was in the United States. And I'll go into that in a minute. So what do we know about risk factors for ALS? So what I'm showing here are, I guess I should have used the lapel mic. So what I'm showing here are these risk factors for ALS, and this is what's known as an odds ratio right here. So pay attention to this column. And this number, a number above 1, indicates that that's how much more times likely you are to have ALS if you're exposed to one of these chemicals. So you can see that if you have an exposure to lead in the past, your likelihood of getting ALS is 1.72 times higher than somebody who's not been exposed to lead. So we see that lead, heavy metals, pesticides, agricultural chemicals, solvent exposures, and electrical shocks are really well understood factors driving ALS risk. And so if we think about the state of Michigan, it's a very agricultural state, it's a very industrial state, so we have a lot of these pollutants in our environment. So let's talk about Guam. Guam's an island in the Pacific. Hawaii is here. And after World War II, the Navy went into Guam and noticed that the incidence of ALS, of this ALS Parkinson dementia complex disease, was 50 to 100 times higher than the US. And this affected the Chamorro population. It was actually the main cause of death in this group in the 1940s, with a median age of onset of 44. So the age at which most people were getting this disease was around 44. It's actually since declined. It's almost non-existent anymore. And there was no clear genetic linkage. A lot of people thought there were so many people getting this disease that a lot of people said, well, it's got to be genetic, it's got to be genetic. But no genetic linkage was found. And there's a couple debates about what the toxins were that were driving this disease. And it turns out that people would consume, a seed called the cycad seed from the cycad trees, and it had a toxin in it, and it would be converted into flour, it would be incorporated into diets and other uses. And this was one theory, that this toxin would lead to this ALS, Parkinson, dementia-like disease. And perhaps the more interesting theory is that there was this thought about bioaccumulation of toxins. And so there's these flying foxes, or fruit bats, that would consume large amounts of these seeds as part of their normal diet, and they weren't necessarily affected by it. And then for whatever reason, these animals are delicacies, or they were delicacies in Guam, and they were consumed, and that these bats would have the toxins that were bioaccumulated. Somebody would eat them, and they'd get really a high amount of this toxin in them, which then led to the development of this disease. But what's most interesting, and what tells us that this was clearly an environmental cause of disease, is that if we look right here, this is the incidence of this Guam ALS in males. This is the incidence of this Guam ALS in females. Right here, this is kind of the peak incidence range, and sort of, or when we first started noticing this in 1944, you can see the incidence of this disease over a short period of time drops almost to zero in both men and women. And that isn't something that genetics explains. So we don't change our genetics over the span of 20 years. So there's clearly an environmental linkage that drove this disease. Now, some people say that the flying fox population declined because guns became more prevalent and it was easier to hunt the foxes. And then shortly thereafter, the incidence dropped. The flying fox one is a little bit more interesting. So clearly monsters under the bed aren't all that we have to fear, and that there's other chemicals that are out there, so pesticides, pollution, lead, and other chemicals. And we're clearly a state that's not immune to some of these problems. So some of you may remember this Michigan chemical company that was in St. Louis, Michigan. They produced a flame retardant, a PBB, a polybrominated biphenyl. And they also produced a nutrient for cattle feed. So one was called Firemaster, one was called Nutrimaster. The bags looked fairly similar, and for some reason in 1973 it got switched. And so the PBB went into the nutrition bag, and these were fed to cattle. 30,000 cattle were affected, 1.5 million chickens, thousands of pigs and rabbits, and they were all destroyed. This is an image from the free press. You'll see them sacrificing the animals because they couldn't be distributed. And amazingly, even now, this chemical is still detected in the environment. It's still in the air. So if you take tree bark samples, you'll find this pollutant in the tree bark. And the cleanup effort has costed over $300 million, and it's not complete. It's still ongoing. And if you look at the measurements of blood in people, so right here, so the people in this that have been enrolled into registries, they have amounts of these PBBs decades later that are higher than the US population average. So they're 95% higher than the US population. And so chemicals that we've been interested in are called persistent organic pollutants. These are chemicals that are made because they're really highly stable. They're meant to last, okay? So they're manufactured to last and for particular qualities. So if they're a pesticide application, you want to put down the pesticides, you want to kill the bugs. You want like a flame retardant to put in your furniture and your clothing so that they won't burn. Or you want something that's going to go into your electrical equipment to help with the cooling aspect of it, to prevent it from catching fire, or add it to other products like paint to make it last longer. And what we see is that the time for these chemicals to reduce in half are in the decades. And so once they get into the environment, they persist. And then through the food chain, through the water, through the soil, through the air, we can get exposed. And so what we see here there's monitoring stations along the Great Lakes. And the top boxes, so if you look at these 4 boxes individually here, keep turning the wrong way. So if you look at these 4 boxes here, 1, 2, 3, 4, these top ones are the cities. So Chicago on the left, Cleveland on the right, and then we get into more of the less populated areas. We see that these chemicals are still detected in the air they've been declining over time. The amounts are higher in the cities compared to the more rural areas, but they're still there. And in fact, some of these types of chemicals are actually increasing in animals and in humans. And so PBDEs, which are flame retardant, are actually increasing in amounts in humans and in fish. So to help us address this problem, about a decade ago, we established, really under the direction of Dr. Eva Feldman, established a national bank of tissue and information about ALS. So this consisted of clinical data. Some people who've seen me and seen our team have provided samples of blood and skin and urine and have completed surveys, and we're so grateful for you doing that. And this is really what helps us learn about ALS. And so our goals are to really look for these environmental risk factors that are associated with ALS, and we measure these toxicants from biospecimens, and we use surveys to help us understand what historical risk factors there have been. So we've paid attention to three major types of chemicals. One are the chlorinated pesticides, organic chlorine pesticides. These are all banned, but they persist, as I talked about. The major one that you hear about is DDT. It's been banned, but although there's still some usage in the world, it's hard to know for sure if it's still being manufactured. But there's some thoughts that it may still be used in China and North Korea. And amazingly, these are detectable in the Arctic. They've never been applied there, right? So they travel. So this is a worldwide problem. The brominated flame retardants are another class that we've looked at. These are also no longer used, but if you have, say, furniture from the early 2000s or before, they could be in there. They were added to clothes to prevent them from catching on fire. And then polychlorinated biphenyls, or PCBs, which were used in electrical equipment, and these also have been banned but persist and last in our environment. And so what we did initially was we looked at what we're finding from information that people give to us in surveys, so risks that they've had, things that they've been exposed to, and the measurements of these chemicals in their blood. And we published this in JAMA Neurology back in 2016, and we were fortunate enough to get featured in the New York Times and actually on the Today Show as well. And one of the first questions that we asked was, what are the occupational exposures that may be driving disease? So we looked at it over the entire occupational lifetime, over the last 10 years before symptoms started, between 10 and 30 years ago, and greater than 30 years ago, to look and see when is this sort of peak risk period from the time you start getting symptoms and when the exposure happened. And so we think about this idea of what's called the exposome, where you're exposed to chemicals, and I'll come back to this, where you're exposed to chemicals and other environmental stimuli from really in utero through your whole aging and adult life. So we had a cohort of 156 individuals that have ALS and 128 controls, so people that were healthy. There were a lot of similarities between the two groups, about the same age. And what we see, and what I'm presenting here, these under the OR, I'll go back, under OR, that's the odds ratio, that's the amount times more likely somebody is to have ALS. What we saw is that if you ever worked in the US Armed Forces, your risk of having ALS was 2.31 times higher than somebody who doesn't work in the Armed Forces. That's really consistent with what we understand, that a military service history is a risk factor of ALS. And if you reported an occupational exposure to pesticides, your risk of having ALS was 5 times that higher of somebody not having ALS. So clearly driving disease. There was a little bit of a, smoking was sort of close to a little bit of a risk factor. We understand that smoking is a risk factor as well for ALS. Interestingly enough, for those of you kind of looking at the data, you'll see that lead was a protective factor. It's less than 1, but there's a lot of, there's some reasons why when we looked at lead in other windows, it didn't look like a protective factor. So I'll just point that out there for anyone looking at all the numbers. So our next question was, we've measured these chemicals in blood, and do these influence the risk of having ALS? And so these are data that we didn't publish. They're a little bit updated. We've looked only at measurements in plasma, so component of blood. And these are 167 people with ALS and 99 control people, so people that don't have ALS. These groups were very similar to one another otherwise. And what we see, so let me explain this graph to you. And so you'll notice these are odds ratios. So these are the times more likely you are to have ALS given this particular exposure to a chemical over here on the left. So you'll see, I'm not sure if I'm projecting here. So you'll see PBDE 28, 47, 85. These are all the different pollutants that we can measure in blood. And this one here, okay, so if this dot or the concentration, or if this chemical makes you more likely to have ALS, it falls to the right of the one here. And if it makes you less likely to have ALS, it falls to the left. And so what you'll see is that a lot of these chemicals fall to the right, meaning each of them individually have a small risk in increasing your likelihood of having ALS. Particularly the box in blue are pesticides, so particularly the pesticides as a group seem to be driving the risk of ALS. And then at the bottom in the red square, what we've done is we've developed a score, we call it an environmental risk score, that summates the total amount of the toxicants that we measure in your blood. And we see that that's really high. So let me move on to the next slide. And we see when we consider all these risk factors for ALS, when we look at people's age, how much they weigh, whether they served in the military, whether they're male or female, we see this odds ratio, so this environmental risk score odds ratio of 7.37. So what does that mean? That means if you're an individual that moves from the 25th percentile of exposure, so from a low group, to the 75th percentile of exposure, your risk of having ALS is 7 times higher, okay? So that is a huge risk. And so these chemicals seem to be playing some role. So we next asked the question, how do these chemicals influence survival, or the length of time that you live? And we published this recently. Unfortunately, we were picked up in the Free Press, who did a front page article. It was below the fold, but it was on the front page. And I was also interviewed on NPR. And so you can go listen to that. If you're not sick of hearing me already tonight, you can go listen to me some more. And we looked at 167 individuals with ALS. These were collected between July 2012 and November 2016. And again, we look at the same graph, the likelihood of an individual living based off of, for a period of time, sort of based off of the measurements of each of these pollutants. So anything falling to the right of one indicates that an individual progressed more quickly if we saw higher amounts of that chemical in their blood. And to the left of that line means they progressed more slowly, falling to the left of that, to the left of the one. And what you'll see is all these dots are falling to the right of the one. So each of these chemicals individually plays a small but noticeable role in the progression of disease. And the bottom box in red is our way, again, of summarizing these measurements to say, okay, let's look at all these measurements as a whole. What are they doing? And so what we see when we think about all these relevant factors, right? So how old are you? Are you male? Are you female? Where did your disease start? Did it start in an arm or a leg? Or did it start in the face? Do you use a non-invasive ventilator or BiPAP machine? So all these things that matter with ALS, what we see is that when you go from, and I'll explain this graph in a second, and I'll say this twice. So if you're an individual in the highest quartile, so we divided this into 4 groups. So if you're an individual in the highest quartile of exposure, your progression is 2 times that of an individual in the lowest quartile of exposure. So what we're finding here is that not only do we think these pollutants increase the risk of somebody having ALS, but then also speed up the disease once you have it. And so what we're seeing here, just pay attention to the graph on the right. And so these are what we call survival curves. And so as these go down, that means fewer people in the group are living with the disease. And you'll see that there's this gap here. Red is the lowest exposure group. This yellowish color is the highest exposure group. And what you'll see is that there's a big difference here between the lowest exposure and the highest exposure. Oh, well that's great. Go blue. You knew I was coming.
Yeah.
Someone's going to play like an Ohio State fight song in a minute, right? And so this difference is about 6 months. So these pollutants are playing a role in how long people are living with disease. So what we've seen is that higher concentrations of these pollutants from plasma are associated with an increased odds of having ALS. Lower concentrations are associated with a longer survival, and that we can see that responses that people give on surveys, so what the occupational history was, what the residential history was, can give us some insight into previous exposures. So life's a drag, right? And we know that there are people that seem to be having these exposures and they never get sick, right? So we all know people who smoked their whole life and they never got sick. And we know people who smoke for like 5 years and they get a terrible lung cancer. And so why is this happening, right? Why are some people just immune? Why are they just immune to disease? And so this whole idea is genes and exposure, right? So now at the beginning I talked about, well, the genes don't explain everything, and then I went on to say, well, let's talk about the environmental risk, and now I'm bringing them back together. Now I'm saying, well, maybe the genes matter. And so I'll read this and then I'll explain it, and I have some examples. So highly prevalent but low penetrant genetic variants contribute to disease, but, and I may have a typo, but many in the setting of a low penetrant environmental exposure. So what does this mean? So we all have these little tiny changes in our genes that's just part of being a human. And the genes just kind of have, there's certain places like an on-off switch, and sometimes, you know, the switch is flipped in one way and sometimes the switch is flipped another way, and most of the time it doesn't matter. And sometimes if you need the switch flipped in the right way and an exposure to make that switch matter, okay? But these exposures, these switches really sometimes just don't matter. You can flip them one way, you can flip them the other way, and it's not going to matter. So we call that prevalent, meaning you can pass these switches, turn one way or another, from person to person to person, and it doesn't cause disease. So we call this a low penetrance, okay? So the switch can be flipped one way, it just doesn't matter. But if turning that switch matters when you're exposed to, say, a chemical or something like that, it's that chemical exposure that then makes the direction of that switch actually matter. Excuse me. So let me give you an example. So here's a group of people, just random sample of people. And let's just say that these individuals now in gray have this switch flipped one way that makes them susceptible to a disease should they get an exposure. So again, let's look at this, and now let's just say a toxic blob comes across the population and exposes a number of individuals to a particular chemical. And that goes away and you go on living your life. And then at some point, that toxicant makes a difference for the individuals that were exposed to it and had that genetic variation. So in other words, the disease gets caused in only those individuals that were genetically at risk and had that exposure, but those individuals that were sort of genetically at risk and never were exposed do not develop disease. The challenge is that we don't know what those genes are, and we don't know how many they are. You know, if it's 10, 100, 1,000. And so this is some of the work that we need to do. The other challenge is that our exposures to environmental toxicants occur throughout our whole lifespan, okay? So all the way on the left, number 1, these are in utero exposures. These are things no one remembers being in the uterus, okay? So these are things that happen where we're in the uterus, we have no idea what's happening, and that happens, and it goes away. And then number 2, these are these accumulated environmental exposures that occur over your lifetime. So things like water contaminants. You just keep getting exposed and exposed throughout your life. Number 3, in the blue, are the occupational exposures. So you enter the workforce, maybe you work in a plant where you're exposed to something, you keep getting exposed to that until you stop working, and then that exposure stops. 4 are things perhaps that doctors do to you. They give you drugs, right? So most people don't take a lot of drugs when they're little, and then maybe they're sick a little bit. They get a little bit of a drug, and it drops down. You get a little bit of drug, and you get older, and everyone likes to put people on more and more medications, so that exposure goes up. And then 5, these seasonal exposures, right? Like the tree pollen comes out, or I'm not saying tree pollen leads to ALS, but these are the seasonal exposures where they kind of fluctuate as the year goes on. So we really, to understand the totality of exposures, or the exposome, we need to understand how these exposures are occurring throughout life. And so a lot of what I've talked about already is related to measurements that we're taking now to try to anticipate or understand exposures that may have happened, say, 5 years before, 10 years before, 20 years before. But how do we measure and quantify early exposures in life? And so some of you that have heard me talk about this, or have heard us sort of talk about our program where individuals can donate brain and spinal cord tissue to us after passing, you say, well, why do you want a tooth, right? Why do you want a tooth? And so it turns out teeth are like rings on a tree. And so if you cut into a tree, you see those rings, right? We all know that kind of a ring shows up every year that the tree is alive. And with the great work of Claudia Figueroa Romero at University of Michigan and Manish Arora, who's at Mount Sinai, New York, what Manish does is he takes a laser into the tooth. And when you sort of do this laser ablation and sort of free up the molecules in the tooth, you can pick them up. And at 2-week intervals, from the age of 0 to 15, you can see what metals were absorbed. So again, let me say that again. So from the age of 0 to 15, at increments of 2 weeks, you can see metals that somebody may have absorbed during that time. So this is really, really powerful, allowing us to not only think about what are the more recent exposures, but exposures before you even knew what an exposure was. And what we see, so each of these graphs represents a metal, and I want you to just pay attention to the red arrows. Because when there's a red arrow there and you see that black line above the 0, let me just see here. So this one will be easier. So this line here, if you're above the 0 line, that means you're more likely to have ALS. If you're below the line, it means you're more likely to not have ALS. So we can see that there's certain windows in time where it looks like individuals with ALS were absorbing metals in higher amounts than individuals with control. So we see this with barium, with chromium, with magnesium, with manganese, nickel, tin, and zinc. Okay? And so the next question is, well, how do we put this all together? So we've talked about that there's a genetic component. We've talked that there's an exposure component. We've talked that there's a connection between how you're exposed to these chemicals over your whole lifetime and how the genes and the exposures may interact. And you say, okay, so what do we do with this? Why does it matter? What can we learn from it? And how do we find treatments, right? And so there's something called metabolomics, where we understand the cellular processes, so what your cells do and how they generate these byproducts or metabolites as they're making energy or kind of going through the normal cell functioning. And there's about 8,500 metabolites that we all have just based off of our normal cellular processes. There's about 1,450 drug metabolites. And at the top you'll see there's about 3,100 toxins and environmental chemicals. And what we can do with these metabolites is really understand how does your metabolism change, how does your cellular function change, and why is it changing, and what are the pathways that it's changing, and then importantly, how do we identify new therapeutic targets using metabolites? So if I, for example, can say that if you were exposed to a certain chemical, this changes your metabolism in such a way, well, that's a new therapeutic target, and there may be a drug that either exists or that we need to go find that can treat this metabolic pathway that gives us a whole new way of treating ALS that's completely unknown right now. So to start looking at this, we've measured what we call untargeted metabolomics. So we just take samples of plasma and measure these metabolites. We've got about 1,000 metabolites in individuals that have ALS and individuals that don't have ALS. And I just want to show you how different the metabolome looks just comparing people with ALS and people that don't have ALS. So on the left, maybe I'll try to use the mouse here. All right. Oops. So this blue bar, there we go. This blue bar here, these are the individuals with ALS. This red bar, these are the individuals that do not have ALS. And the colors here represent whether a metabolite is increased or decreased in somebody. And what you can see, you don't have to do any fancy statistics or anything to look at this, but what you can see in general, there's a real difference in color between people with ALS and people that don't have ALS, right? There's no fancy statistic I need to give you, no odds ratio, no p-value, nothing like that. You can see, wow, there's a difference in the way the metabolism looks between people that have ALS and people that don't have ALS. And when we look at, when we sort of summarize these, what we call partial loop squares analysis, we can see that these groups really segregate out. So in red here, we flip the colors. So in red here is the group with ALS, and in blue, these are people that don't have ALS. And you can see that these chemicals really tell us who has ALS and who doesn't. And so what we're doing now, and these are not data that I'm presenting tonight, but what we're doing now is really digging into these biological pathways and saying, okay, so what are these pathways that seem to be turned on or turned off or activated in different ways in people that have ALS? And how can we take advantage of what we understand about normal metabolism and changing metabolism and how they all interact and work together to say, here's a new treatment opportunity for ALS. So that's what we're moving towards. And then also saying, well, if you're exposed to a chemical, how does that metabolic pathway change, right? And how can we look at the metabolites and understand what you've been exposed to without ever measuring a chemical, a pesticide, a metal, or whatnot? How can this give us some signature of why somebody's having symptoms? And so these are really powerful data. We're really excited to be digging through these right now. And hopefully, if I'm invited back in the future, we'll have more data to go over. So what do we need to do in the future to keep solving this problem and to keep making inroads on our understanding of ALS and finding new therapeutic targets? So we need to expand the longitudinal exposure measures. So people who come to clinic, it's like, okay, the vampires are coming in, we're getting more blood from you, right? So we need to understand how these measures are changing over time so we can get a sense of how exposed someone has been. We have to understand these genetic and exposure interactions. How can we use surveys and information you've provided to us, or people that have participated in our study, to understand what exposures have been in existence in the past and how these exposures influence the risk of getting disease, the progression, and why does an ALS that one person has look so different than the ALS that somebody else has, right? When you see other people, you're like, wow, you look different than me. Well, why is that happening? And can the exposures be telling us something? And then we have to identify these metabolism changes that help us figure out why disease is happening and how can we find these targets. So what can we do? Well, this is where it's sort of a call to action, right? So participate in research. So this is key, right? So, and not just clinical trials. So sometimes clinical trials aren't fair, and there's these inclusion-exclusion criteria, and you just can't get in. But we have research for everybody. And this research into understanding the risk factors for ALS matter. It makes a difference. It allows us to go in new directions, and we need everyone to participate for us to better understand this. So this is plug number 2 for the National Registry. Register. So the CDC was charged in 2008 from an act of Congress to start tracking and understanding disease, who gets it, where do they live. There's a portal where you can fill out risk factors. You can volunteer to have your blood collected by the CDC, so this is in addition to like what we would do at University of Michigan. And you can be notified of research opportunities. So maybe somebody says, hey, I've got this research study, and if you're so-and-so, you may qualify for this, and reach out. So you can help us understand who has ALS. You can provide information about risk factor surveys, similar to what we do in our clinic. So do them both. You can get notified of research opportunities. And this really allows us to know who's living with ALS, where are they, how many people, how do we allocate resources, how do we push funding out, how do we advocate, right? How do we provide the programs that people need with ALS? And then also, if I'm a researcher, how do I connect with individuals that have ALS? How can I make people aware of research opportunities? And then how can I use those data to allow the research community to better understand ALS? So it really matters. And then advocacy efforts, right? So advocacy efforts for ALS. So why does it take forever to get a power chair? Why do I need to wait to a certain period of time to be eligible for a breathing machine? Or why can't I get my AAC device right away? And why do I need to go through all these loopholes to sort of get something that I need? And so advocacy is really, really important. And so get involved. And there's efforts, formalized efforts through like the ALS Association and other groups. And then financial support of research is huge, because these are the gifts that allow us to sort of take things in new directions before they're really ready for a grant. So I think it's as a researcher. So I'm a clinician researcher, and again, I see a lot of familiar faces in the audience, and it's nice to see everybody away from the clinic. And it's really important for us to stay connected to people and to family members, especially when individuals provide samples and things like that to us. So you can go to our website, you can sign up for our newsletter, and that allows us to stay connected. We don't use it enough. Probably anyone that's signed up for it has probably received 1 or 2 emails. And so it's just finding the time to send out an email. But that allows us to say, when we find something from the research, how do we share that with you? And then we're not enrolling right now for any clinical trials, hobefully several in the near future. But if you're interested in learning more about the research, there's an email address there, ALS studies, so 2 S's, that's monitored by our research team. So here's our funding. We can't do this research without our funding. So the Centers for Disease Control, we've had 2 grants, one from 2013 to 2017 that have really helped us establish the resources. We have an ongoing one to look at the metabolomics, and then I'm funded by the National Institutes of Environmental Health Sciences. And there's a lot of people behind this research. I'm standing here in front of you today, but there's teams of people, and these faces are going to look familiar to you. And so here's all the names. You'll notice our research coordinators that many of you may know: Jana Duell, Blake Swihart, Amanda Williams, Scott Dent, Daniel Berger. These names are familiar. Eva Feldman has been really important for driving this work, and the individuals in her lab, and individuals in the School of Public Health and Environmental Health Sciences at University of Michigan and in biostatistics. So thank you. Sorry again I was late, but I'm happy to take any questions. Great, no questions. Go ahead.
What's your feeling about the stem cell treatment going on in Mexico?
So I don't know about the particular thing that you're referring to. I would say that stem cells are still in the research realm, and we don't know if this is a hopeful, exciting therapeutic avenue. And we've done our own studies at the University of Michigan, but it's still a research It's still in the research realm. And so it's important for individuals to participate in research trials of stem cells, but this is not a therapy that's ready for prime time and to be rolled out for you to go seek out or pay for or whatnot.
Sir?
Is your PowerPoint available to us?
It's not, I don't think, but it looks like this was videotaped.
Well, the presentation's being videotaped.
Oh, okay.
Do you have any thoughts on the length of telomeres in terms of chromosomes and the effects on disease?
I don't. I don't. It's not something that we've looked at, and I'm not familiar with. I'm not familiar with the literature on that with ALS.
In your slide about the environmental risk scoring right before about the negative impact of survival, where you had all of the factors listed, it seemed that some of the
chemicals
things, yeah, the chemicals, seem to be more harmful possibly than others.
Yeah. So
With those particular pollutants, like some of the ones in the yellow maybe were worse, maybe some of the PCBs
Yeah.
versus the other. Is that just a perception thing or is that reality?
no, that's something that we noticed as well. That the pesticide risks seem to be driving the likelihood of having ALS, whereas it was the PCBs that seem to be popping up more in terms of the progression or the pace of disease.
Okay, and then just as a follow-up to that, then is that something that outside of the study is looked at, or it's just not at this time just because it's research?
Yeah, so these are really not measurements that are commercially available.
Okay.
So there's really sensitive techniques that are used to measure this. They're called gas chromatography, mass spectrometry methods, where you're looking for these hits of these ions passing through really like a laser to see when they're popping up. And it's not done commercially, so we're looking at these in small amounts.
Thank you so much.
Yep.
So, in terms of the environmental toxins, is there any thought or is anybody consideration of can the body be cleansed of any of these toxins?
Yeah, so what can I do, right? How can I take this information and how can I, knowing what you're telling me, what do I do about it, right? So we don't know yet, right? So we don't know what the therapeutic options are. So I think that's where the metabolomics is going to take us. So what are the things that you can do now that we kind of know from the CDC and know from good recommendations what to do? So, there's recommendations to avoid things like great lake fish because they tend to have higher amounts of some of these pollutants. You can go onto the CDC website and see which fish are more where you're encouraged to eat, versus other ones that may be more likely of having, say, metals or other chemicals. There's this, push, should I eat organic or non-organic, because they may have some of these foods. We know from sort of like the lead story in Flint that, fruits, fresh fruits in general can help remove some of these, these compounds. And then we really need to get them out of the environment. And so part of what we need here is a public health effort to say, look, do we have enough information as it is already to go through some of these cleanup efforts, right? So we hear at least the story that seems to be occurring every week in Ann Arbor is this PFAS story, and there's this leakage of these chemicals that are getting into the Huron River and getting into the water supply. And so what do we do to sort of stop some of these environmental problems that we know are coming?
Aspect of twice the occurrence of ALS in the military as the general population. Is there any thought, is there even speculation as to why? Because now you're talking about people that are coming from all different parts of the country that are experiencing overall this higher level of, or incidence of ALS. And is there a common factor within the military? I think of one, but
So this was really understood well under after the first Gulf War, when individuals that were younger were coming down with ALS and noticed that there was this risk that was twice as likely for people to serve in the military. And so there's not a common factor that's been identified. There's been a lot that's been thrown out there, like could there have been a chemical exposure, could there have been, say, different fuels, could have been burning the gas as individuals were kind of going through the Gulf. Could it be physical activity? So individuals that are highly physical active, it's probably a risk factor for ALS. These are the types of exposures that have been considered. There was a question, yes.
Doctor, is there a way to test these fluids in your blood? If there is there a way to remove any of it?
So is there a way to test for the chemicals in the blood, and if you find them, is there a way to remove them? So there's not commercially available testing for these chemicals in the amounts, and so we don't. So it's a complicated question. So
Especially among young.
Yeah, so there's not really commercially available tests where I can say run your blood through it and kind of report back results and look at these and really identify what these compounds are. There's some commercial labs out there, but they're using different methods and may not necessarily detect them in the ways that we can detect them in our studies. And in terms of removing them from your body, these are, we don't know this yet, right? So we're not recommending any types of removal of these toxicants. They tend to get stored in fat, and there's some concerns as if you lose fat, they may come out into the bloodstream more. But it's avoiding ongoing exposures, which is one of the keys. So avoiding the foods and say like Great Lakes fish and those types of things that may have higher amounts of these pollutants in them.
Where do you find that list of foods?
So the CDC has recommendations. Yeah, if you Google like CDC and fish recommendations, they talk. There's a whole list of things that they recommend for sort of healthier foods that are less likely to have some of these environmental chemicals in them.
There are an awful lot of trials out there, and I've noticed that there are several that have advanced to the, 2, 3 phase. I wonder if you have any opinion on any of those. Are they really promising? And do you have any idea at all how close we're getting to a cure?
So what's my opinion on the different trials that are going on? Do I know the results? And are one of these drugs sort of promising for a cure? So of the trials that are ongoing, I don't know results. The trials that I'm involved in, I'm blinded to the data. So there's 3 types of clinical trials that you hear about. A phase 1 study, which is where you're really trying to understand the toxicology of the drug. Does it have a negative impact? A phase 2, where you're trying to see, is there any biological possibility that this drug could be having an impact? To then move on to a larger study to say whether or not this drug works. And so there's a number of drugs right now that are kind of into this phase 2 transitioning to phase 3. And there's a number of studies right now that are in phase 2. And I don't know the outcomes. These are things that nobody knows until the data come out. And all research is good. And so participation in all research in clinical trials is really needed. There's barriers to participation in clinical trials, whether it be enrollment criteria or traveling to a research site. And we have a hard time, enrolling people into clinical trials for all these reasons: the uncertainty of what you're going to get, the fact that you may get a drug or a placebo. But it's really, really important to participate, because without that, we just don't know. And so, I don't know where every day we're closer to a cure, right? And every day we're closer to finding more and more about this disease, but I can't put a timeline on when that one drug or combination of drugs is going to come out to stop disease and turn it around.
environmental toxins. You talked about clinical exposure, such as medications. I've heard that there are some common medications that are viewed as neurotoxins. And I can't, off the top of my head, I can't think of what some of those are, but have any of those been looked at? Are you aware of some of those, and have they been looked at as an impact?
So are there any sort of prescribed drugs that may be
Yes.
a risk for ALS? So there's none that are, in the literature right now, there are no drugs that are saying if you've been given this drug, this prescription drug, you're at a higher likelihood of having ALS. So in the past, there have been a concern about, say, statin medications,
Yes.
so the lipid-lowering medications, and that story didn't pan out necessarily. So in terms of prescription drugs, there are not data at this time to tell us that a particular drug is driving ALS risk. There are some individuals who are looking into that and have sort of ongoing research into that, but I don't know what they're finding. All right. Well, thank you so much. It was really an honor and a pleasure to be here talking to you guys tonight.
Thank you.